Good afternoon, Year 10. This is Mrs. Finlay, and we are looking at the sine rule. Trigonometry has been very useful to us so far and helped us find unknown angles and sides in triangles. What kind of triangles? Right-angled triangles, I hear you say. Well done. Well, what if we have a triangle that's not right-angled? Let's explore this thing called the sine rule. Our learning goal, straight from the syllabus, is here. Establish the sine, cosine and area rules for any triangle and solve related problems. Well, today we're going to prove the sine rule in any given triangle, and we're also going to use the sine rule to find unknown sides and angles of a triangle. For this lesson, you will need your exercise book, pen or a pencil, ruler and a protractor. So pause the video if you need to and go and grab them. Okay, let's do some drawing. Draw any triangle that you please. We're all going to have different triangles in our books. Here's one I prepared earlier. Now use your protractor to measure the angles and mark them on your diagram. My angles are already on the diagram. Use your ruler and measure the side lengths and mark them on your diagram. Perfect. I've measured mine at 5 centimetres, 6 centimetres and 3.5 centimetres. Okay, find your biggest angle. Here's my biggest angle, 80. Now where's your biggest side? Okay, well what about your smallest angle? Here's mine, 30 degrees, and your smallest side. Oh, that's interesting. They're opposite. We're going to examine this relationship and see if we can express it succinctly. Now to make this part easier, let's draw the same triangle now. Capitals for angles and lowercase for sides. A, B, C, marking your sides, lowercase a, lowercase b, lowercase c. Now this isn't a right-angled triangle. I wonder if there's any right-angled triangles hidden inside it though. It might be easier if we draw our altitude in. Call the perpendicular height h, and the point where the height intersects with the interval AB, we'll call that x. Wonderful. Let's look at this right-angled triangle, ACX, and see what we can do with that. Here it is, ACX. Well, we could say in triangle ACX, sine, now remember your right-angled trigonometry from Year 9, so katoa. So sine of angle A is equal to the opposite, H, over the adjacent, B. Now rearranging that to make H the subject gives us H equals B sine A. Alright, well let's look at this right-angled triangle here, CBX. What can we say about that? In triangle CBX, sine B equals the opposite, H, over the hypotenuse, A. And rearranging to make H the subject again, we get therefore H equals A sine B. Well, we now have two expressions for exactly the same height. Well, it's exactly the same height, so we can equate those expressions, and we would write that as this. B sine A equals A sine B. Well, it would be nice if we could get our A's and our B's together. So we can tidy this up by dividing both sides by sine A, sine B. and these will cancel, and these will cancel, and we're left with B on sine B equals A on sine A. This is the sine rule. On to the second part of our learning goal, using the sine rule to find unknown sides and angles of a triangle. In this first example, our unknown is clearly a side labelled A. Do we have enough information to use the sine rule? Yes, we do. Make sure you check. Our tool is the sine rule, so tell the marker what you're using. A on sine A equals B on sine B. Wonderful. Substituting our values, A on sine of its opposite angle, 25, equals 11.3 on sine of its opposite angle, 42. Rearranging so that A is our subject, A equals 11.3 sine 25 on sine 42. Plug that into your calculator, and when you do, you will get A equals 7.1 centimetres to 1 decimal place. Is this answer realistic? Yes, a smaller angle goes with a smaller side. Alright, example number 2. We are looking at angles, and I'm going to show you F. Again, our tool. Tell the marker. This time we're looking for an angle. Sine A equals sine B. Substituting our values in. Sine F over 14.7 equals sine 93 on 20.7. Rearranging, sine F equals 14.7 sine 93 on 20.7. Now remember, when you put this in your calculator, to use sine inverse. When you do, you will get F equals 45 degrees to the nearest degree. Wonderful. Well, tomorrow in class we'll be practicing applying the sine rule. And finally, as a challenge, I want you to take a look at these two triangles. Use the sine rule to find angle C. I can't wait for your questions tomorrow. Bring them to class. And remember the hint. We are using the sine rule, so think about the unit circle and the graph of sine between 0 and 360 degrees. Wonderful. Get excited to examine the ambiguous case.